Right, this is our last video within the Hungarian algorithm. Okay, so what we're going to be doing is assignment problems, but this case is going to be unbalanced. Okay, once again, similar to the maximizing one in the previous video. Okay, there's only really one extra step that we add into this. Okay, which makes it nice and simple because effectively the skills that we've done previously are all the same. Okay, all right, unbalanced. Everything we've done so far has in fact been a square matrixy, which basically means that if we have 4 tasks, we have 4 people to complete those tasks, right? Or if we have 3 tasks, we have 3 people to complete this task. Now this is easy, okay, because what we have is we have it all in balance. But the problem for today is what happens if we have it as an unbalance, all right? In other words, we might in fact have 3 tasks, but we may in fact have 4 people to complete those tasks. So it becomes unbalanced. So in other words, someone may in fact miss out on the task, right, which is okay. That's just the way it's going to be. So what we're going to do is we're going to address this by inserting a dummy row or a dummy column. It needs to be added in order to convert it back to a square matrixy. Okay? Right, all the elements that you're going to insert with here are going to be the elements of 0, which does in fact make it very easy to do. Okay, that's the only extra step that we would want to do here. All right, now this is going to be done in the first step before we do anything else. If it's also about maximizing, you would incorporate the other step as well once you have done this. Okay, perfect. So here we go. We have 3 tasks here, and we've got these 4 people here. All right, and in this case, we want to determine the minimize the total time taken for these people to complete these tasks. All right, first thing we're going to do is we're going to incorporate this as a square matrix, okay, which is going to now look like this. So effectively what we've done is we've added in this dummy row. Because we've got 4 people down here, is that we need to have 4 columns, right? So we've got the first column, second column, third column. So I've inserted this dummy column here of all zeros, okay? That's the only extra step that we need to add in for this question in order to accommodate for this imbalance here. So from here, everything else from here is exactly the same. Now, since we're subtracting each row, every value, the smallest value in each of those rows is going to be 0, which does make it very easy because by subtracting the rows, you probably don't even need to rewrite it because they're all going to be exactly the same. So in other words, what I would do is I would go straight to subtracting the columns effectively, okay, for this example here. So subtracting the columns, once again, identify the smallest number in each of the columns, which are underlined there, and go ahead and subtract each of the columns like so. Okay, and there's each of the columns subtracted. Once you've done that, is that we're going to go to our next step. All right, drawing the lines to cover up. Now, it'd probably be a pretty good idea to draw a line over the last one because there's 4 zeros in that line. Can we cover up the other ones like so? Perfect. So this is a nice easy one because we've got 4 lines, 4 rows, so we can go straight to allocation now, which is good. If it didn't, we'd go back and do that balancing task that we did before by the subtraction, stay the same or add. Okay, and now correspond to each of the zeros. So we have a 0 in the first row over there. We have a 0 here in the second column. We have 1 0 in the third column, and we have 1 0 in the first column as well. Making sure each of these zeros are in different rows as well, which they are. So now, related back to the question, correspond those numbers. 0 for 20, for 40, for 30. So what happens with all of this? Pierre gets job A, Eleanor gets job B, Joel gets job C, but Darmini gets the dummy job, so in other words, she does not get a task or a job here. Adding in those values, the minimum value is in fact going to be 90. Okay, very much the same as what we've previously done. Okay, this time we're going to maximize, and once again what we can see is we've got 3 people here and we've got 4 jobs. Okay, so basically what's going to happen is that there is in fact going to be a job which is going to be incomplete, which is okay, doesn't matter. So firstly, start up by writing it as a square matrix like so. We need to insert this time the zeros across the bottom, okay, because we want to make it into a square matrix. From here, all right, maximizing. So once again, choosing the largest value which is C within the whole matrix C, okay, which in this case is going to be 18. Subtract every value from 18, which is going to be like so. Once we've done that, all right, run through our standard process, subtract rows. Smallest number in the first row, 3, in the second, 0, third, 2, fourth, 18. As we do that, subtract all of the rows, we end up with this. There we go. Lots of zeros appearing. And once we've done that, we're now going to subtract the columns. Zeros for all of them, so that's a very boring subtraction because it's just going to be exactly the same as what's just above. Use your line to cross off all the zeros. Alright, 2 lines, nowhere near it at this point, so we're going to have to do some balancing here. So identify the smallest number, which is uncovered. In this case it's 2. Subtract that. Add it to the one which is covered up by 2 lines, which is that bottom left one, and subtract it from all of the uncovered ones, like so. See how many lines it requires you to draw. This time it's 3. Still doesn't work, so we need to repeat that process. 1 is now the smallest number, which is uncovered. Once again, keep all of the singular covered lines or numbers the same. Add it to the double covered ones and subtract it from the uncovered ones, like so. Try again. Once again, we've only got 3 lines. We need to repeat that same process. 1 is now my new number. Once again, anything which is covered by 1 line stays the same. 2 lines, adds, and there is my next one. Okay, subtracting it from all of those uncovered ones. Again, draw the lines, looking for double ups, and now we finally have 4 lines and 4 allocations. Perfect, so now we can start allocating these zeros to where they need to go, looking for single zeros in a column or row, and working from there. So in other words, there is 1 0 in that row, which means we cannot use that one at the top. So therefore, if we cannot use that one at the top, in the first row, it means we have to use this 0 here, which means we can't use this 0 because we've already got 1 0 in this column, which then means we'll have to use this 0. And since we've got a 0 now in this column, is we cannot use that 0, so therefore we're going to have to use that 0 there. Okay, correspond those each to where the locations are. 16, 12, 15, and the dummy row is not there. So therefore, job D won't get completed by no one. 43 units, and there is our solution. Okay, hopefully this is starting to stick this process. Good luck with it all. Thank you.